So the last section in chapter 5, we're looking at dividing polynomials by a binomial. The key here, as we mentioned in the last section, this is going to be a completely different approach. And before we get to the approach, there's two things we want to make sure we understand. One I've kind of referenced, but we'll officially define it and enforce it and stress it here in this section. That is putting a polynomial in what's called descending order. That's just writing the terms in order from left to right, from highest degree to lowest degree. So the exponents. X to the fourth here in this polynomial being the largest exponent. I'll write that term first, the negative 5x to the fourth. Then the next highest I see is an x squared, so plus 2x squared. Then the 3x, and we say constants have a degree of 0, so they'll always go last. That's it. Just talking about order, but that's going to be important. And the reason it's important is because of the next idea. Because what we were going to need to do for these problems and these problems only, you will never do this really anywhere else in algebra, but for these kind of problems, division by a binomial, the process we use, it's very important that we do something called filling in missing terms. What that means is, as you go to put these things in descending order, let's just start. I'm going to start with the negative 5x to the fourth. That is the highest power, the highest degree. Now, just notice above, the next highest power was an x squared term. What we mean by missing terms is that this polynomial does not have an x cubed term, but we're going to want to write it with one. We don't want to change it, so we say there are 0 x cubes. Now, that might seem strange, might seem like that's just going to make this thing look uglier and bigger and more complicated, but there's an absolute reason for it, and we'll see it on the next pages. Other than that, I've got my x squared term, I also have the x term, and the constant. So that's it. That is all it takes for that particular polynomial to fill in those missing terms. Let's look at one more. This is pretty exaggerated. You won't really see this in the problems, but it just helps emphasize the idea. Starting with the highest power, 2x to the fourth would be the highest power. Notice there's no x cubes, so I need plus 0x cubed. There's no x squareds, so I need plus 0x squared. There is an x term, so I get a plus 5x. There's not even a constant, so I'm going to throw in a plus 0. Now again, that's kind of exaggerated for lots of missing terms. You will not see that here in this class for these problems, but that is what it would mean to fill in the missing terms for an example like that. And so these ideas, specifically the missing terms part, but that goes along with the descending order, those are going to be crucial to this approach that we're going to look at. The approach we're going to use for dividing by a binomial is referred to as long division. And it is very similar to the process of long division that you use for numbers. So similar that we're going to do these two problems side by side to show how close they are, how similar they are. Here are the steps that we will talk through, but I don't want to read them through right now. We'll see them as we go. The one step I will read is what I call step 0. It's the setup step, and it's that thing we just saw. We make sure that our polynomials we're working with are in descending order and have missing terms filled in when we put them into that long division format. So remember, the long division format is just that kind of division symbol where the thing you're dividing into, right, this guy, what we call the quotient, goes up top, and x plus 2, the thing you're dividing by, goes outside. I just realized I called that the quotient. That's the dividend, and this is the divisor. The answer we get is the quotient. So with this polynomial, notice it's x squared, x, and a constant, all in order. For the binomial, it's x and then a constant, in order, no missing terms anywhere, right? That we checked that as we write that form. So now that we have that form, the process starts. Let's go over to numbers real quickly, and let's write them in long division form. And let's talk about this process. The very first step you do with long division is you look at your number out front, and you try to figure out what it goes into without being the entire number. Well, 12 doesn't go into 1, so we look at 12 into 15, the first 2 digits. 12 goes into 15 one time evenly, right? If you took it 2 times, 12 times 2 is 24, that's too big. So you can find one set of 12 in that 15, and you put that one up top, okay? That step of asking for 12 into 15 goes once. Over here in polynomials, looks probably the most different. This is the completely, very, very separate, very different looking step. Because here, if I asked you how many times does x plus 2 go into any part of this, that's just confusing. There's no easy way to answer that. So we don't do that. We don't look at the whole x plus 2. We start by just looking at x and the first term here, x squared. So I call this the first into first step. I say if I have an x and I want to have an x squared, x times what gives me x squared? That's my question. What do I multiply x by to get x squared? Or another way to think of it is x squared divided by x gives you what? Leaves you with what? You can think of it either way, whichever way your brain works. But the idea of what would you multiply the first term in the binomial by to get the first term in the polynomial? X times x would give me x squared. Or again, if you thought of it as x squared divided by x, that's where that's coming from. We're going to put it right there. Now here's the thing. Notice I didn't put it above the x squared. There's an organizational reason for this. I'm going to put it above its like term. When I ask for x and x squared and I get x, I'm going to put it over my x term. It lets everything be in nice, convenient columns, but also notice it lines it up like the 1 did over here over the 5. And that's also for a reminder. Because, go back to the numbers. This 1 right here, once you say 12 goes into 15 one time, what do? You take that 1 times this 12, and you see how close you got. That's what we're going to do with this x. Even though you get this x by just asking for what I call first into first, right? X into x squared, you're going to take it times the entire binomial. Now, here's the thing. X times that x has to give you x squared. That's why you chose it. If those don't match, you did something wrong. But it's the next term that's really the idea of the how close. X and 2 gives me a 2x. But now, back to the numbers, because when you're dealing with the numbers and you get to this step, when we say how close do we get, we then subtract to find out. 15 minus 12, leaving me with 3. That's how close we got. 12 went into 15 one time with 3 left over. Same thing here. To do the subtraction step, you got to be very careful. I always put a minus sign in parentheses and a result bar to show we're subtracting down both columns. X squared minus x squared is going to go away, right? Those are like terms. 1x squared minus 1x squared is gone. Here, 5x, but then you got to bounce over to the minus sign. 5x minus 2x, right? 5 minus 2 is a 3, so that's going to be a 3x left over there. That subtraction step is a step you got to be careful with, and especially on the second column, making sure to incorporate that subtraction sign correctly. That's the key. Now, back to numbers. Once you get that subtraction, you bring the next digit down, 36, and you're ready to start over. Same thing here. Bring the plus 6 down, and you're ready to start the process over. Notice it says bring down the next term, and then repeat back to step 1. So, over to the numbers problem, I'm going to go through kind of all the steps, just right in a row of the numbers. It's 12 into 36, which goes 3 times. 3 times 12 to see how close you got. Well, gives me 36. Subtract 0. That means 12 went into 156 evenly 13 times. Over here, same thing, only different because it's that first into first. That question of x times what gives you 3x? Or, again, 3x divided by x, that's what you're looking for. Well, it's just the 3, right? X times 3 would be 3x. So the 3 I'm going to put right above my constant term, right? Keeping these like terms aligned again. That's where my first into first goes. But now that I've got it, I multiply it by both terms. 3 times x is 3x. 3 times 2 is a 6. Then once I've got that, I subtract the result. 3x minus 3x is gone. 6 minus 6 is gone. So there's nothing left over, which now that, again, it sounds weird in the polynomial world, but to say that x plus 2 divides into this evenly with x plus 3 left over as a result. And x plus 3, that thing you write above that line, that is your answer. Just like over here, 13 is your answer. Now, that was our process. We went through 2 what I call cycles of it. I don't expect that to make perfect sense yet. This is a very involved process, lots of steps, and very specific things you have to remember to do. But once you practice it enough, nothing ever changes about this process, and that's the good thing. Every problem you practice, you're going to get a little better and a little more familiar with it, because this process will never change no matter what's going on. And so we're going to do some more examples and show you that. There's just one thing we have to add when this value here is not a 0, when it doesn't go in evenly. And we're going to see that on the next example. All right, so we got both examples, again, polynomial and number. I'm going to run through the entire number example just to talk about what I just mentioned. 12 goes into 13 once. 1 times 12 is 12. Subtract is 1. Bring down. Right? That's the cycle right there. 12 into 15 is 1. 1 times 12 is 12. Subtract is 3. Now, there's nothing left to bring down. This problem right here, if you were to see this question in an arithmetic class, there's lots of ways you can do this problem. You could throw a decimal down, start throwing in zeros, and keep bringing zeros down and get a decimal answer. You could go with a much earlier approach, which just is to call this number the remainder, which is what it is, the remainder, and put a R3 up here, right? But the way we want to understand this number in this class for this purpose is that this 3 is a 3 out of the next group of 12 that we were looking for. So 12 goes into 135 11 times evenly, right? 11 times evenly, and then there was 3 out of the next 12, so 3/12, which can be reduced to 1/4, which I should write, but I want to focus really on that idea. It's the remainder out of the divisor, right? What you were dividing by, 3 out of 12. So that's a mixed number is all that is, right? That's how you write a mixed number. So we're going to keep that in mind as we come over here to the polynomial problem. So we'll put it into the long division form. Notice they are in descending order and missing terms filled in. So we can just copy them down. And so now we start the cycle. X into x squared, right? X times what is x squared? Well, again, that's just x. Now you've got it. Multiply it by both terms. X times x is an x squared. And x times 2 is a 2x. That's the result, which we want to subtract. Subtracting down both columns, x squared minus x squared is gone. That should always happen. And then 3x minus 2x is 1x. Bring down that 5, and that's one full cycle, right? First into first, multiply, subtract, bring down. That's a cycle. Start the cycle over. First into first. X times what is x? Well, that's just a 1. So, plus 1 up there. 1 times both these terms. Multiply. 1 times x is an x. 1 times 2 is 2. There's your result. Subtract. Down the columns. X minus x goes away, and 5 minus 2 is a 3. Nothing left to bring down. There's that 3. So it divided into it this many times, if you want to call it evenly, but it had some leftover. So our interpretation here is very important. We get x plus 1 plus the additional remainder of 3 out of x plus 2. Okay, so it's the same idea. You write the remainder over the thing you divided by, which looks a little weird in that fraction form. Also very important that you put a plus sign here if this is a positive and a minus sign if it's negative. You don't want to write this fraction just right next to that last number, right, last term. Because even in a mixed number, when you write this, when you say 11 and 3/12, you're saying 11 plus an additional 3/12. You just don't write the plus sign because we don't do that in mixed numbers. There is a plus there. It's 11 plus the additional, so it's this guy plus the additional. And so that's our form if we have any kind of remainder left over in these long division problems. And that's basically all this bottom of the page is saying, the remainder over the binomial, and just kind of a summarizing of that first into first, then multiply, subtract, bring down, repeat, cycle. Okay? So with that, let's just take a look at a couple more. Get some more practice, because that's all it takes, is get some familiarity here. Okay, this guy divided by a binomial. As soon as you see the binomial, that's when you know you need the long division symbol. starting with 3x to the fourth, but notice here, it goes from fourth to squared, so we need to throw in a 0x cubed. There was no x cubed term there. Now we do have x squared, but also there's no x term. So we'll throw a 0x in as well, and then we end up at our constant of plus 2. So a couple missing terms there. X plus 1 looks good. So now, lots of cycles is what we're going to do here, okay? So first and the first, x to 3x to the fourth. Okay, well, we need a 3 to get from a 1 to a 3. And if this is x to the first and we want to get x to the fourth, we need 3 more x's, x to the third. So we need a 3 x to the third. Again, if it helps you to think about in the division sense, it's this term divided by that term to give you what goes right there. Okay? But 3x to the third multiplied by both terms gives us 3x to the fourth, and then just times a 1. This will be a nice easy one, multiplying by 1 every time. Just gives us that term. Now we're going to subtract, okay? 3x to the fourths are gone. For the x cubes, it's 0 minus 3, right? 0 minus a 3 is a negative 3. So that'll be negative 3x cubed. And then we'll bring down the x squared. Starting our cycle over, first and a first, x to negative 3x cubed. Think of it as negative 3x cubed divided by x leaves you with a negative 3x squared. And you check it. Negative 3x squared times x is negative 3x cubed. Those got to match. Negative 3x squared times a 1 is just negative 3x squared. Now you go to subtract and there's a ton of minus signs. Don't let them confuse you. These still go away because it's negative 3 minus negative 3. Minus a negative is like plus. So negative 3 plus 3 is gone. Here, be careful. It's 1x squared minus a negative 3. If you got to write it off to the side, do it. 1 minus a negative 3. Well, minus a negative 3 is again plus. So this is really a 1 plus 3 on these x squareds, giving us a 4x squared. That's very important. You gotta pay attention there. You gotta know how to use that minus sign. It's a very common mistake for people to see this and say, so it's 1 minus a 3, so that's negative 2. And we don't want to do that. Minus a negative determines what's actually going on there. So 4x squared. Now, even though the next term is a 0x, well, I'll still bring it down. We still want to see it. We go on to the next cycle. First and the first, x to 4x squared, or again, 4x squared divided by x, will be just 4x. Multiplying gives me 4x squared, and times the 1 is a 4x. So we'll subtract. Those are gone. And for the x's, 0 minus 4, right? So it's minus 4. So that's a negative 4x for a result there. 0x minus 4x. Bring down the 2 for our final cycle. X to negative 4x, right? We're asking, what do you multiply x by to get negative 4x? Well, just the negative 4. So negative 4 times that x is the negative 4x. Negative 4 times the 1 is negative 4. But then we go to subtract those. Negative 4x minus negative 4 is negative 4 plus 4 is gone. But over here, 2 minus negative 4. Minus the negative 4 is plus. So this is really 2 plus 4, giving me 6. Since that was our last term in our last cycle, that 6 is our remainder. That's our divisor. So it's all of this, again, since 6 is positive, plus 6 over that x plus 1. And all of that would be our result. And I just realized that bottom of the work was off the screen there. Sorry about that. Give me a second to see all that there. All right. And one last one, which is actually way easier than the one we just did. We've got that polynomial divided by a binomial. We have no missing terms at all, so that's convenient. We just have that divided by that. Essentially, I wanted to have an example where our binomial had something other than just x out front, just to show you how we're working through this first step especially. So same question, 3x times what gives you 9x squared? Or 9x squared divided by 3x is what we want, which would be in this case, 3x. 3x times both terms gives me a 9x squared and a minus 6x, which we will then subtract. Now this is 6x, so those are gone, sorry. And then 6 minus a negative 6 is like 6 plus 6, so that's 12. So 12x, and then bring down the 10. And one last first into first, 3x to 12x. 3x times what is 12x? Well, that would just be a 4. So 4 times 3 is 12x, and 4 times negative 2 is a negative 8. So we go to subtract. 12x's are gone. 10 minus a negative 8, right? So 10 plus 8, so 18. And so we have our 3x plus 4 up top, and that 18, it's positive, so plus 18 over the 3x minus 2 for our final answer.